Alright, so in this problem we'll take a look at how to factor using the second method that we talked about, a trinomial, right? So this method is called the AC method, or the grouping method sometimes. Trinomials are the form by grouping, or trinomials, factor trinomials, or factor trinomials by grouping. So that refers back to the four-term technique that we knew, that we used previously. So when should you use this technique? You should use this technique when you have too many choices. So for example, consider this problem. Say we had to factor 6x squared plus 19x plus 8. Now here's the problem with us. So if we try to do this with trial and error, by the way, trial and error works, and if you like trial and error, you should by all means use it. It turns out that trial and error is a whole lot faster than this when you get good at this, and if your arithmetic's pretty good. But here's the problem with this method. Remember how we did trial and error? We looked at one of these corners and we fixed that corner, right? But the problem here is that 6x squared, there are many choices, right? So there are choices. This could be either 6x and 1x, that's one choice, or another choice could be that this could be 2x and 3x. So now your choices are exploding. And so for the 8, again, you have many choices. This could be 1 and 8, and we know that we could also have 8 and 1, right? And it could be 2 and 4, and it could be also know that it could be 4 and 2. So now your choices are exploding. Now, having said that, I can tell you that we can eliminate a lot of these choices very, very fast. But you have to be really good with your arithmetic in your head in order to do that. So I would recommend that you use AC method when you start to see choices, a lot of choices at either end, right? And so let's take a look at the AC method. So factor 6x squared plus 19x plus 8 using the AC method. Right? So there are a series of sort of lockstep steps to go through here. And now the process gets its name because we name a trinomial this way. Right? So in our problem, A is 6, C is 8, and B is 19. Right? So that's our problem. So the first step of this process is actually there's a step 0, but for this problem I'll start with step 1. Okay, is to multiply A and C, and that's where this gets its name, right? So over here I'm going to create a 2 columns, and we'll see why in a minute. So AC is equal to 6 times 8, which is equal to, let's see, 6 times 8, 48. Right? And then you want to find pairs of numbers that multiply 2AC but add 2B. Okay, so B in this case is 19, so I want to find a pair of numbers that multiply to AC while adding to B. So it must multiply to this and add to 19. Okay, so you already have a pair of numbers, and it may not be the right pair, but it's always a good starting point. So 6 times 8 we know multiplies to 48, and 6 plus 8 is equal to 14. So the reason I say that's a good starting point is because if the number 14 in this case is less than 19, means we need to make 8 bigger and 6 smaller, and so that way they will add to a bigger number, right? So I know in which direction to hunt for factors. So for example, I will try to make 6 smaller. So 6, can I make 6 smaller? 5. 5 doesn't divide 48. How about 4? 4. Does 4 divide 48? Let's see. 48 divided by 4 gives me 12. 4 and 12, right? 4 times 12 is 48. 4 plus 12 is 16. Okay, so I'm getting closer, but still not quite there. So the next step would be to go down one more. So how about 3? So 48 does divide by 3, right? So 16. So we have 3 and 16. 3 plus 16, is that 19? Yes, right? So what I have found here is the pair of numbers that I'm looking for my second step. Now this is not the answer, right? This is not the answer. So this third step is, and this is the critical step, to rewrite bx, the middle term, using the pair of numbers you found. Okay, so step 3 over here. So what I have here is the problem 6x squared plus 19x plus 8. Now I know 3 plus 16 has to be 19. So instead of 19, I am going to rewrite this using 3x plus 16x. Now the order doesn't matter. You could have put 16 first and the 3 second. It would still work out to be the same thing. And you get that. And now you factor by grouping. Okay, why? Because this is now a 4-term expression. So you can factor this by grouping. So you take the left pair and you very carefully look for a GCF. So we know 6 is 2 times 3, and so you know 3 is common to both. So it's as part of the GCF, you know you're going to get a 3, and then you look at the x's, and this is the exponent of 1, so the least exponent is x1, so that's in your GCF. And then you're left with 2x, and in this case a 1. And we know that if we get 2x plus 1 here, it must also be here if you factor by grouping. And so we can look up and say, okay, so that's a 1, so that means this has got to be a plus 8. And does that work? 8 times 1 is 8, 8 times 2 is 16. Indeed it does. Now we do a GCF again, and we have 2x plus 1, 3x plus 8. And you're done. That's it. This is the answer. Now, some people think that this is a long process, and don't like this method and prefer the trial and error method. Fine, use the trial and error. Some people just love this and this is all they will do. Fine, that's fine. This works all the time. What people like about this is there is no guessing, right? You're just basically figuring out this pair of numbers, which you can do in a nice systematic way, like I shown you here in this table, and then you basically split the middle up and factor and group, and you get your answer. Done. End of story. So some folks really like the fact that you don't have any uncertainty as you work your way through this method. All right, so we'll look at more examples coming up in the next video.